Namaste students, I Javin Indu, Assistant Professor, Department of Science and Technology, Faculty of Education and Archaeology, Jayoti Vidyapeeth Women's University. Today I will discuss a numerical problem which will be based on Maximum Power Transfer Theorem. So let's start. The question says, in the given network, find the value of RL which will absorb the maximum power from the source. Also find the maximum power. This is the given network. In this network, we have to find the value of this RL at which we have to find the value of this RL. This RL will absorb the maximum power from the source, and we have to also find the value of Pmax, means maximum power. So first of all, we will find the value of load resistor for, that's why here we will use the steps which we used in the Thevenin's theorem, because we know that at RT equals to RL, maximum power can flow through the load resistor. That's why when we get the value of RTS, then we can find the value of RL. That's why for RTS calculation, we have to find the value of VTH also. So for VTH, we will remove the load resistor RL from here. So when we remove the load resistor RL, then we will get two open ends here, A and B. Across these two open ends, we have to find the value of VTH. So first of all, we have to identify the number of meshes which will be present in this circuit. So there are two meshes are available. In the first mesh, we assume that current I1 is flowing in the clockwise direction, and in mesh 2, current I2 is flowing in the clockwise direction. So in the mesh 1, 5 ampere current source is already available. So there is no need to apply the mesh in this mesh. There is no need to apply the KVL in this mesh. So I1 will be 5 ampere, because the direction of I1 and the direction of 5 ampere current source is the same. That's why I1 is the 5 ampere. Now we will apply KVL in the mesh 2. So we will get the equation minus 10I2 minus 24 minus 5I2 equals to 0. When we solve this equation, then we will get the value of I2 equals to minus 1.6 ampere. For VTH, we have to find the voltage drop across this 2 ohm resistance and the voltage drop across this 5 ohm resistance. So in the 2 ohm resistance, I1 current is flowing, and in the 5 ohm resistance, I2 current is flowing. So we can easily find out the value of voltage drop across 2 ohm resistance and 5 ohm resistance. So across 2 ohm resistance, voltage drop will be 10 volt, because I1 is 5 ampere, the value of resistance is 2, then V will be 2 into 5, it will be 10 volt. And across this 5 ohm resistance, voltage drop will be 5 into minus 1.6, that is minus 8.0 volt. So now we will draw the voltage equivalent diagram in the form of voltage drops. So here we took VTH because these were the open ends, 10 volt minus 8.0 volt. When we will apply the KVL in the clockwise direction, then we will get minus VTH minus 8 plus 10 equals to 0. So VTH will be plus 2 volt. Now we will remove the RL and replace all the active sources by their internal resistances. In this circuit, we will remove RL firstly. After that, we will replace the 5 ampere current source and 24 voltage source by their internal resistances. So 5 ampere current source will be open circuit and 24 voltage source will be short circuit. So our circuit will be this one. Here we remove the load resistor RL. We That's why we go to opponents A and B. From here we will calculate the value of RTH, and this will be short circuit branch because here 24 voltage source was available. That's why voltage the internal resistance of the voltage source is 0. That's why we will replace that source by short circuit branch. Here was the 5 ampere current source. The internal resistance of the 5 ampere current source is infinite. That's why 5 ampere current source replaced by the open circuit. So we will get this circuit. So RTH will be 2 plus 10 parallel 5. So it will be 5.33 ohm. So in the first of all we have to find the value of RL now. So RL equals to RTH. We know that the value of RTH. So RL will be 5.33 ohm. So this is the value of load resistor for maximum power flow. So now we will find the value of maximum power which will be flow through that load resistor. So formula is that Pmax equals to Vth square upon 4 Rth. So Vth is 2. The value of Vth is 2. So Pmax will be 0.187 watt. So I hope you are satisfied with my today's digital session. If you have any query, please mention in the comment section and I will resolve it on the live session. Thank you.